at 2.3, they want you to solve these questions, radical equations graphically. First what I'm going to do is I'm going to look at what we would have done last year to solve a question, and then we'll look at how it relates to this year. So algebraically, last year, this is how we'd solve a question. If I have 7 is equal to square root 12 minus x, add 4. Now, like everything we did last year, you have to work with restrictions. So the first thing you want to do is list your restrictions right now. So your restrictions are basically this. 12 minus x has to be greater than or equal to 0. Right? Can't have negative value inside that square root. So now we solve for it, just to find out what it is. And that means then that x is going to have to be less than or equal to 12. Okay, so it can't be any greater than 12. Now make sense of that just for a second here. Give me a number greater than 12. 13. So what's 12 subtract 13? 1. Negative 1. Right, so just simple optics, we can see that that's got to be value. Now this is what we list as our restrictions, okay? So that's part of our final solution. Now let's just solve it and see what happens. So I subtract 4, sorry, get 3, square both sides, subtract 12, x is equal to 3. Does that fall into our solution? Right? So our solution be x is equal to 3, x has to be less than or equal to 12, checks out. Okay? So far so good. Put the value in. 12 subtract 3 is 9, square root of 9, 3 add 4 is 7, we got it right. Okay, so now let's take this exact same question, and let's use our graphing calculator to solve it now. So I have, what I'm looking at then, is, actually before I do that, I want to quickly run through again. This isn't what you're going to have to do, but I suggest you do it just so that we get some more practice on what we have done to this point. And that is this. I'm going to graph this side. So y1 is equal to 7. Okay? And then I'm going to graph this side over here. y2 is equal to the square root of 12 minus x, add 4. Okay, and then I would find the intersection. Now, just wait before you get going on your calculator. Let's take the square root 1 and let's talk about where it moves. Okay, so what's the first thing that you see I have to do in order to, with this guy right here? In order to do the transformation without the calculator, what would I have to do first? Okay, well then let me pose this question to you. Where is it going to transform to? Where is y equals the square root of x going to end up? Yeah. Okay. So right now you could say 4 up, but we can't work with this. Not the way it's written, right? So I have to take the negative 1 out, make that x minus 12, add 4 out here, right? So now, what are the three? There's 3 transformations here. What are they?
You're going to times all your y values by 1, so
yeah. Okay. Not necessary, but sure. You're right. Divide by x value by negative 1. Yeah. And up 4. Exactly. So my 0 and 0 is going to be 12 and 4. Right? Okay. So that's just it. And again, all I'm doing here is practicing. I want to practice this and make sure that I understand it. Now I want you to graph y1 equals 7 and y2 is equal to that and find out where the intersection point is. Now remember, our starting point is 12 and 4. Okay, so your window is going to have to be greater than what it is. I would probably put your window to minus, I don't know, 20, put it up by 2's, minus 20 and 20, and find out where the intersection. Where's your calculator? Okay, then graph these.
What does x res mean? This is x res.
Okay, just leave it as like that. Okay. Okay, do we get an intersection point?
Again, so
Good. Intersection point of 3 and 7? How many of you actually use intersection? Second function, calculate intersection. Yeah, okay, good. So it was, it's 3 and 7, right? Well, x is equal to 3. When I solve it, it's going to give me y equals 7. We know that. Right? Now, there is a secondary method that you can use. I'll show you the secondary method because we've already done the secondary method last year. All right, so the secondary method, is everybody okay with this one first? You found your intersection point. Gabby, did you find your intersection point?
no, I'm trying to find this.
What's your problem?
Trying something else because it didn't work the first time. I think it's just how I punched it into the y equals. So I just changed that because it didn't work the first time.
I can't be there. This has to be there if you're going to do it. I wouldn't do it, but that's your call. We have 2 sets of brackets. Why are you here this twice? That was nothing when I talked to you. Y1, 7.
My bad.
Now put it in. Square root 12 minus x plus 4. Now I grab it. Windows in there. Okay, so the second way in which you want to do this, or you can do this, would be to move in the actual equation, move the 7 over by subtracting it. So I would get this, y is equal to square root 12 minus x, subtract 3, right? Then I would graph it and find out what my 0 is, because it'll cross the x-axis, and it'll cross the x-axis at the x value, which will be 3. So your solution will be 3 and 7 again. Does that make sense? So the two methods are graph each side of the equation and find out where they intersect, or make it one equation and find out where the zeros are on it. Again, we did that last year when we were trying to find where graphs intersected. Okay? All right. Let's look at example 2. So it says solve the equation 3 plus square root x minus 1 equals x algebraically. All right, so we have right there, right? Wants us to solve it algebraically. So this is actually a bit more, we did this again last year. Okay, so what's the first restriction that we have on there? What's the restriction?
X has to be greater than or equal to 1.
Greater than or equal to 1, good job. Okay, so x has to be greater than or equal to 1, we know that. All right, so now how do I solve this algebraically? You guys remember? Well, how do you solve anything ever algebraically? What's my objective? Isolate x, right? but we have an issue because we have a square root right now, correct? So, the first thing I need to do, and we did this again, isolate that guy. So I go that, right? Now I can get rid of the square root by squaring both sides. But the trick is, it's not x squared subtract 9. It's x minus 3 all squared. So what do you get? You get x minus 1 equals x squared minus 6x add 9. X minus 3 times x minus 3. Get everything to one side. Now what? How do I solve this now?
Square.
Could. Tougher to do. It's tough to do because you got an odd number in there. So what else do you do? What's the number one thing you always do? Factor it. Can you factor this? Right? Okay. All grade 11 work so far. Right? Now, we have to make a better point of checking because this may or may not work. Stick 5 in there, for example. So 5 subtract 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. So 5 works, right? Okay. 2 subtract 1 is 1. Square root of 1 is 1 plus 3 is 4. But that's actually what? So there you go. Here's your first look at an extraneous root. Okay? So on your exam, this is how you would do the question, and this is how it would look. Feel free to check it in your head. Alright? But you do need to show both solutions and X out the one that doesn't work. Okay? Again, we started doing all this last year.
Will there always be one that doesn't work?
No,
or
not necessarily.
can there be, okay.
It could be none that
Almost
work,
neither.
both could work, one that works, right? So it's,
In my test, I erased it 5 times. So I thought there had to be one, but it just didn't work.
no. You're right, it may not work at all. Okay? That's it. Alright? So, 2.123, we're done. Test Tuesday. We'll get a pre-test to you later today, or not probably later today, because we don't have class tomorrow. And we're Friday, and we have no school Monday. Okay?